These are the notes for Unit 10, Worksheet Day 12. I'm going to run through and just do some of these examples, not all of them, but enough variety to give you an idea of how to solve or how to graph any of these other problems that you may have questions on. So first things first, you don't have to do this on every problem, but it's probably a good idea to just write our vertex formula. And then we can kind of use those components to decide where everything belongs and how we're going to graph each of these functions. The vertex comes from that HK. We're going to start, though, by identifying our A value. I don't see a number there, so it's just 1. Our vertex, remember we do the opposite of H because in the formula it is a minus. So this is going to turn into a positive 1, and then that K value is going to stay positive. Our axis of symmetry is a vertical line that runs through the vertex. So it's x equals 1. So this is the one that informs the axis of symmetry. My slope values are 1 times a, 3 times a, and 5 times a. I'm not going to do this for every other one, but this is probably a good idea, at least in this first one. This is actually how I'm going to count the slope. 1 over 1, 3 over 1, 5 over 1, or if I can get that far. We'll save the domain and the range until the end, but we'll start with 1, 1 is my vertex, and then we're going to graph our 1a, so 1 over 1, 3 over 1, and then 5 over 1. So we're just going to go 5 from here, so at the very end. And then we're going to use that axis of symmetry to just mirror those points. You can count the exact same way, just with a left instead of a right, if that helps. And then just do your best to make sure this looks like a parabola. That's a pretty good parabola. And our domain of all these quadratics, if you look at the graph, it's opening to the left and to the right forever. So negative to positive infinity. It has a bottom at 1, and then it's going up forever. And the other thing we're going to tie here is the 1 here, the k value or the y coordinate of the vertex is going to be your range. All right, so I'm going to move through this next one a little bit faster. So we have a slightly different a value. We have a -2. My vertex is going to be at +5, +9. My axis of symmetry again, that comes from the 5 in the vertex. My slope values now are going to be -2 over 1, -6 over 1, and then -10. So that's my 1 times a, 3 times a, 5 times a. If I want, I can fill in the domain and range now if you understand how to do that from the vertex. Otherwise, we always have our graph to look at. So 5, 9. Now we're going to go down to right 1, and then we're going to go down 6, right 1, and then we're going to go down 10, right 1. And then we can mirror up those points, or you can count it to the left instead of to the right. But I like mirroring those points. And now you can see it's a little bit narrower. This is going to be a little bit trickier to draw, so I'm just going to do my best to draw a nice parabola here. It's opening down. My domain, as we said earlier, for all these functions is going to be negative to positive infinity. Now my range has no bottom, so we're going to have negative infinity, and that goes up to 9. It has a maximum value. Again, make sure that you're recognizing that this y coordinate of the vertex informs my range, but it's upside down, so you can think of it as upside down, the range gets flipped. All right, next one, we have another a value of 1. My vertex, we do the opposite of that +5. -3 stays -3, it's outside the function. My axis of symmetry is -5, and we're just going to go 1, 3, 5. Pretty boring. The domain is negative to positive infinity because it's quadratic. You can square any number you want, but we can also get that from the graph. So it's totally up to you how you want to play that. Here is my vertex, up 1 to the right 1, up 3 to the right 1, and then up 5 to the right 1. And we'd like to make sure these points are all pronounced. So when I'm drawing my vertex, I should see, whoops, I missed there. I should see each of those points. All right, that's what we want. We want to see those points in the nice curve. My range, we go down to -3 and we go up forever. Okay, and then this last one, what if we just have like a plain old boring -1? That is gonna, we're gonna count it the same way. We're just gonna count that negative slope. So kind of like we did with the -2. Again, we grab our vertex -2, +6. My axis of symmetry always corresponds with the x-coordinate. And then we're going to go -1, -3, -5. My domain is, again, negative to positive infinity. Now, the range is going to get flipped. And if you're ever having trouble, I like to use the graph here. So I'm going to go -2, 6 is up here. We go down 1 to the right one, down 3 to the right one, and then down 5 to the right one. And we do the same thing on the other side. You can see that nice parabola. And we draw our curve. And there we go. So you could, again, ask yourself on the range, what is the bottom? The bottom is negative infinity. It's going down forever. And then it goes up to 6. That is the y-coordinate of the vertex. Okay. So that's how we're graphing those quadratic functions. You could try the rest on your own, but let's take a look at just these shifts. So the shifts they're just asking me what's going on with this. So if you think about it from the origin, from 0, 0, this vertex is 10, -7. So that means we have a horizontal shift where the vertex is going to go right 10, and it's going to be moved down 7 units. Okay, now this question could be rephrased as, is A negative? Right? Is that A value negative? In this case, my A value is 9, so it's not reflected. But to go right down to 12, I'll kind of answer this one backwards. Because A is equal to -1, right? We have this -1 out here. That is going to reflect over the x-axis. It's going to make us flip upside down. My horizontal shift now is going to be left 2, right? Because I do the opposite of that +2. And then the vertical shift always kind of does what you think it's going to do. That's a +6, so it's going to go up 6. Now this one, we got to be careful here because we have a graph where there is no h, so it's 0, -10, right? Which means there is no horizontal shift. But there is a vertical shift that is going to move everything down 10, and that -5 is going to flip us upside down, so that's going to reflect us over the x-axis. Okay, so the rest of those are pretty straightforward. You should be able to do those other graphs. Take into account, obviously, like on number 14, sometimes our coordinates for our vertex can be 0. Thanks for watching the video.